This is HID Remapper Custom Board V8. Like all HID Remapper boards, it has a great descriptive name, but compared to the others, it seems to be lacking a USB input port. Instead, it has this 3.5mm jack. It's meant to be used with analog joysticks and triggers that you can plug into it using a TRRS cable, which is just a 4-wire audio connector normally used for headphones with a microphone. Let me show you how you can use it to connect an analog joystick to your computer or any other device that takes USB inputs. This is the joystick that I'm going to use. You could use any device that's compatible with the Xbox Adaptive Controller or the PlayStation Access Controller, or essentially any device that has potentiometers inside, ideally 10K potentiometers. If you're making your own device, the only thing you need to know is to wire it like this. Okay, these are the potentiometers and their wipers are connected to tip and ring 1. Let's plug the joystick into the HID Remapper board using a TRRS cable, and let's plug the HID Remapper into our computer. Okay, now let's open the HID Remapper configuration website. If you haven't seen this before, this is how you configure HID Remapper. You don't have to install any software on your computer, you just go to this website in your browser. When you plug a device into HID Remapper for the first time, and you're not sure what inputs the device sends, the best place to start is the Monitor tab. First, let's connect to our HID Remapper. Open device, connect. Let's go to the Monitor tab. We can see that it's already showing some things. The joystick has 2 axes, so we have 2 values. When I move the joystick around, we can see that the values change. When I move it left and right, the first value changes, and when I move it up and down, the second value changes. The theoretical range on these analog values is from 0 to 4095, with the middle or neutral position at 2048. But we can see that the values don't reach the full range, and that the middle point is somewhere near 2000, but not quite precisely 2048. This will depend on your individual hardware. Fortunately, we can correct for that, so you don't have to worry too much about adjusting the potentiometers. Okay, let's do something with these values. Let's make it work as a USB joystick. Let's set the emulated device type to switch gamepad. Let's make 2 mappings, one for each of the joystick axes. I'll set the outputs to left stick X and left stick Y. What will the inputs be? We can't use the analog values directly because these outputs expect a range of 0 to 255 with the neutral position at 128. So we're going to use expressions to scale the raw analog values to the range we need. Let's set the inputs on these mappings to expression 1 and expression 2. Expressions are a way to perform some calculations to create mappings that are impossible with the basic system that just matches an input with an output. They're like a little programming language with its own weird syntax that I'm not going to explain in detail here, but it's basically reverse Polish notation. I'm just going to say what each part does, and if you want to know more, take a look at the documentation. Okay. As we have seen in the Monitor tab, the inputs we are getting from the joystick use these hex codes. Let's copy that. Fetch the input state. This gives us the number with the neutral position around 2000. So let's subtract 2000. We also remember that the value was in the range of about 500 to about 3500. So that's about a 3000 difference from the lowest value to the highest. We need to scale it down so that it fits between 0 and 255. Let's just multiply it by 0.1 for now. You can of course adjust all these values after you do some testing. So now we have a properly scaled value, but it's centered around 0, and we need to be centered around 128. So just add 128. And finally, make sure it doesn't exceed the legal range. We clamp it to be between 0 and 255. This gives us a value between 0 and 255, centered around 128, which is going to be our x-axis. We do the same thing for the y-axis, we just change the magic number at the top. Change 0 to 1, okay. Save this configuration to our HID remapper. Now, because we changed the emulated device type, we also need to unplug it and plug it in again. This is a one-time thing, you don't have to do it after every configuration change. And let's see if our joystick works. Let's go to a gamepad testing website. Let's move the joystick. Great, it works, except up is down and down is up. Ignore the right stick for now. The inversion is no problem, we will just invert it in the expression. Where we multiply it by the value of 0.1, we'll instead multiply it by minus 0.1. Save the configuration to the device. And now up is up and down is down. And this is how you can use HID Remapper Custom Board V8 for analog inputs. In real life, you might want to add some more things, like dead zones and maybe some non-linearity to the axis, but these are the basics. Of course, because this is HID Remapper, a joystick doesn't have to work as a joystick. We could easily make it work as a mouse, or make it scroll documents, or pretty much anything else. Okay, that's it for now. If you have any questions, please leave a comment. Take a look at the project's GitHub repository for more information about HID Remapper and what else it can do. And thanks for watching.